Good evening, friends. Hope you all are doing well. So, yesterday we have seen about the interior of the earth. Hope you guys have understood. We have seen about rock cycle, and I have given you a question about rock cycle and how does it happen? How does it occur? So, most of you have written good answer. Friends, I just want to mention over here. I have seen everyone's answer. You guys are writing good answers, but when you know that we have to write 150 words, so try to make it 150 words. Okay, it will be good if you try to make it 150 words because there is too much to write. Definitely, 150 words are very minuscule, and you can definitely uh, try as much as you can to write 150 words. So, when we say rock cycle, how does it happen, and we have to discuss about this. Then first you explain what is rock, definition of rock. You can talk about definition of minerals and how rock forms. Then you can enter into the rock cycle. So rock cycle, you start with the molten magma, then you go to the igneous rock, then you can write down the properties of the igneous rocks. Then you can go to the sedimentary rock. Here you can write about properties of the sedimentary rock. Then again, how sedimentary rocks are formed, a little bit of that you can write. You can write the example of each and every rock. Then you can write, then you can move towards the metamorphic rock and how these metamorphic rocks are formed, what are their properties, what is an example of metamorphic rock, what are the degrees of metamorphism, that also you can write. And then again, you can write about how it melts and get back to the molten lava, and then again this rock cycle gets completed. In the end, you should mention that it is not necessary that all these cycles should go step by step. Any rock can be converted into the any form in between on or in intermediate stage. So this is required to be written in the answer. So most of you have written the answer. So I'm hoping that all of you still haven't started to write the answers or watching the video lectures or reading the NCRTs. So don't take it very lightly. They are very, very important. Now UPSC is moving towards NCRT. So it is very important that you should pay attention to the NCRTs and don't directly jump onto the difficult portion of the UPSC. Okay. So today we are going to see the next chapter, Our Changing Earth, chapter 3. So here in this chapter, we are going to see a little bit about various forces that are emanating within the earth and what changes that create on the surface of the earth. Then we are going to see the processes on the surface of the earth which affects the already created various structures on the surface of the earth. So let us move towards the our changing earth. So first of all, let us talk about various movements of the earth. In second or third chapter in the sixth NCRT, we had seen about little bit movements of the earth. So these little bit movements that what we were seeing that about endogenetic forces and exogenetic forces. So here these endogenetic and exogenetic forces are discussed in a little bit detailed manner. So before moving towards endogenetic and exogenetic forces, let us understand about lithosphere. So what is a lithosphere? So previous lecture we have seen that earth is made up of various layers. The uppermost is crust, below is a mantle. So lithosphere is made up of crust and an uppermost part of the mantle. So combined together we call it as a lithosphere. This lithosphere is continuously floating on a plastic magma. Okay, so there is a magma beneath the lithosphere, so like a ship which floats on the water. Similarly, this lithosphere floats on that molten magma. So there is a molten magma in below the lithosphere. So we are all living on the lithosphere, and this lithosphere is like a huge ship which is floating continuously on the magma. Getting it? So this lithosphere consists of oceanic crust. It consists of continental crust. A part of mantle also it consists of. So these different uh, parts, or we can say the lithosphere is not an intact thing. It is not a whole thing. It is divided into multiple parts. Okay, it is made up of small little parts, like they are floating on this molten magma. So like you can see, if I keep let us say, so you'll say if they are broken, then we should see the gap in between and we see the lava down there, but it is not like that. So for example, if I keep some few hundred ships of very huge size in the little bit portion of the lake, and if you fly above that and you see down, so you won't see the water because entire surface is occupied by the ships. But these ships are not like stick to each other. There is a gap between them, but it's a very minute gap, so you won't be able to see the water below. So similar way, these plates are very huge and large plates. They are very compactly arranged with each other. They are almost touching with each other, so you won't be see the gap and the lava down on which these plates are floating. Okay, so these are known as lithospheric plates, and they are continuously floating on this we can say ocean of lava or ocean of magma. Getting this? Now, these lithospheric slabs, or we call it as a plates, they are not at all stationary. They keep moving from one location to another location. But this movement is not very fast. Slowly, they move, like we can say 1 centimeter per year. That is the speed. You won't be even able to understand the speed. Currently, we are living on the huge plate and it is continuously moving towards northward. But you won't be able to understand it because the movements are very slow. Like I said, 1 centimeter, or let us say half a centimeter per year. It's like that speed they are moving. So if you want to understand the exact movement of the plate, you will require millions of years of observation where these plates have moved for further few kilometers away. Getting this? So these plates are keep on moving. So that's why we say Earth moves. Getting it? So what makes the movement of the Earth? So definitely the lava on which it is floating. Okay, it provides the energy. It provides the energy for the movement of these plates above the magma. So these plates which are floating on the magma, it is getting energy from the lava. Many times this lava itself is moving. This lava is not a cool lava to remain stationary. It is a very hot lava. It is continuously boiling. So when there is liquid boiling, as you know, when milk you keep it on boiling, it will the lower layer of colder layer of the milk will be at the base. It will become hot and it will come up. Similarly, the cooler layer will go down. It will get hot and again it will rise. So continuously rise of hot milk is going on inside the bowl. Similarly, rise of hot lava is continuously going on below the Earth's lithosphere. So this continuously moving of the lava is because of this force or heat. We call it as a endogenetic force. So here endo means what? Endo means inside. So this force is generating from inside the earth. So this is the first force which is responsible for the movement of the earth. And second force which is responsible for the movement, we can call it as an exogenetic force. So this exogenetic force does not move the earth in a huge quantity like endogenetic force. Endogenetic force will move the entire plate. It will create the entire mountain. It will fold or create a crack inside a plate. But exogenetic force, it will do the erosion. It will do the weathering. So it will move little bit of sand from the surface from one part of the earth to the another part. Getting it? So a river will move a little bit of sediment from the mountain to the ocean. Getting it? So in this way, endogenetic forces create huge impact in a small amount of time. Exogenetic forces also create impact, but this is a small impact. So slowly it is also creating this small, it is also creating huge impact, but in a very larger period. Getting it? So it will, exogenetic force will erode the entire mountain, but it will take few million years. Getting it? But endogenetic force, when lava comes out, it may create mountain within a month or within a year. Getting it? So endogenetic force create huge impact in a small time. Exogenetic force create huge impact, but a long period of time it will create. Getting it? Endogenetic forces are very, very strong compared to exogenetic force. Getting it? So formation of the continent, breaking of the continent, creation of the mountain, and folding and faulting of the particular plate is done by endogenetic forces. While erosion of the mountain, formation of sand dunes, formation of glacial moraines, and let us say formation of floodplains are the function of exogenetic forces. So here on the screen you can see this flow chart, very important to remember the earth movements. Okay, so earth movements can be classified into two types: endogenetic, created by endogenetic forces, and because of the exogenetic forces. Okay, so endogenetic forces can be very sudden force. Very sudden means what? Like within a second, something will happen. And second is diastrophic force. Slowly something will be built up. So sudden force can be classified into the three types. Earthquake, as you guys know, suddenly for 20 seconds it will shake and it will destroy the whole continent. So this is earthquake. Like it will create a huge tsunami. So sudden force, earthquake is a sudden force. Second sudden force is volcano. Suddenly the crust of the earth will break up and the molten magma from the this below the lithosphere will come up. So it can happen within a few days or few hours. Okay. So this is a second sudden force. Third is landslide. As you guys know, landslides, they are also very dangerous. And suddenly when you are trekking somewhere or you're going with your vehicle and traveling somewhere, suddenly a huge stone comes and falls in front of your vehicle and you're calling it as a landslide. You know, entire village can go down to this under the soil or rocks because of the landslide. So these are the very important sudden forces. Then the brother of this sudden force is diastrophic force. This diastrophic force, it builds something. For example, it is building a mountain. It is creating a new continent. It is creating a new plate. It is destroying an old plate. So diastrophic force are little bit slow. They are not very fast. Like to create one plate, it will take a few billion years, 100 billion years. So to destroy one plate, it will also take few billion years. So there's diastrophic forces. Getting it? So these are the two types of forces: sudden forces and slow forces or diastrophic forces. So these are the forces or the movements happening inside the earth. So it is happening inside the earth. Another force or another process is happening on the surface of the earth. They are known as exogenetic forces or exogenetic processes. So exogenetic processes, what gives power to these exogenetic processes? So there are agents of these exogenetic processes. Who are these agents of exogenetic processes? So there are four important agents of these exogenetic processes. First is river. Second is wind. Third is sea wave. And fourth, the most potent, is glacier. So these are the four important processes or forces of exogenetic processes. Now these exogenetic processes, for example, river. River is originating on the mountain. So what river will do? River will erode that mountain vertically. So while eroding that mountain vertically, it will create valley on that mountain. So this is called as an erosional feature of the river. But now that material it has eroded from that particular valley, once its power gets reduced or it dwindles, it will deposit that particular material somewhere down. So this is known as a depositional feature. So exogenetic forces create two types of features or landforms: erosional landforms and depositional landforms. Getting it? So we are going to see few of these erosional and depositional landforms further. So I hope this is very important chapter and this is very important from prelim point of view and mains point of view as well. Now, let's move towards one aspect of this endogenetic and exogenetic processes. Okay, so let us understand endogenetic processes, or we can say sudden processes or sudden forces. Okay, so sudden forces, first understand about volcano. So, what is an volcano? So, volcano is nothing but a hole created on the crust of the earth, and this hole is directly connected to the bottom of the lithosphere, to the source of magma. So since this hole is created, so like right now you can see it's a hole, or it is a vent, you can call it as a vent or opening, who is directly connected to the source of magma over here. Getting it? So this source of magma we can see over here in this region. So this source of magma, so this magma rises from this hole and comes on the top or on the surface. It's called as molten material. It erupts suddenly and comes on the top of the crust. Now, this volcano we are going to see in detail. So here you can understand there are various parts of the volcano. Like it has a pipe, it has a source, it has an opening, and there are different names to these types of volcano depending upon the type of lava which comes out of the volcano, and the type of explosivity that volcano carries. So depending upon that, we will be classifying this volcano in the different types. So I hope you guys have understood this is a volcano. Volcano is nothing but a vent on the surface of the earth through which a magma rises, okay, or it erupts suddenly. Now, this is one aspect which has been given to you. Second sudden, or let us say the spontaneous process, we can call it as an earthquake. What is an earthquake? So, earthquake is nothing but when energy releases inside the earth because of the breaking of a few rocks, or we can say two rocks, they are meeting very violently with each other, and because of that, energy has been released over there. So, this released energy create vibration. It creates shaking inside on the surface of the earth. So this vibration, they reaches different parts of the earth. We are calling it as a earthquake. Getting it? So these vibrations are releasing on the different parts. They can reach very long, with long distance they can reach. So where this energy is released inside the earth, it will definitely release at certain point inside the earth. That point is known as a focus of the earth, focus of the earthquake, where exactly energy has been released. Now, if you take a point on the surface of the earth just above the focus, the closest point you have taken, this closest point is known as the epicenter. So the point above the focus, closest point above the focus on the surface of the earth is known as the epicenter. So epicenter is the first place where the earthquake waves will reach because it is closest on the surface. Getting it? Okay. So that is why the major, we can say the major, for example, this is the epicenter. Below that you have focus. So the maximum damage will happen around the epicenter. And as you go away from the epicenter, then you have very less amount of damage happening there. So closest to epicenter you have maximum damage, and away from the epicenter you have less amount of damage. Getting it? Okay. So these earthquake waves, after this energy is being released, the waves which are being generated, they are known as earthquake waves. And these earthquake waves can be classified into the three types. So they have different characteristics that we'll see, I think, in the 11th standard NCERT. So P waves, S waves, and surface waves or L waves. These are the three types of waves. So depending upon the properties mentioned in the physics, we can classify them according to longitudinal waves. So P waves can be called as the longitudinal waves. S waves can be called as the transverse waves, and L waves, they are known as surface waves. So these primary waves, they'll reach on the surface and they will be getting converted into the surface waves. So this detailed also we are going to see when we'll see 11th standard NCERT. So this is about the earthquake. Earthquake is measured by a particular instrument known as a seismograph. So this is seismograph. You will see in the news they will show the particular machine. So like a circular machine, and it has some pins connected to it, and to that pin is it has some ink in that pin, and they can draw a particular graph. Okay, so that's why it is known as seismograph. It will tell you the intensity of the earthquake. So, earthquake is measured through the seismograph, and the scale through which it is measured is known as a Richter scale. There is one more scale known as Mercalli scale, okay, but the maximum scale which is used all around the globe is Richter scale, okay. So we will see Mercalli scale also when we will see next NCERTs, okay. So we can classify the earthquake into the very strong, stronger or low intensity earthquake, or very, very major earthquake. Like while reading to the news channel, the news reader will tell you the major earthquake had struck Nepal. Okay, or very strong earthquake had struck Delhi, NCR region recently last night. So they are not using the words loosely. They have certain meanings. What is the mean by very strong earthquake? So if the earthquake is more than 6 Richter scale, you can call it as a very strong earthquake. If earthquake is more than 7 Richter scale, then it is a major earthquake. Like in Nepal, in Afghanistan, okay, they are very, very major earthquake. Even the tsunami which struck the Tamil Nadu, okay, that was a major earthquake, around 9 Richter scale earthquake. Okay, so almost if earthquake frequency or earthquake intensity it goes below 5 Richter scale, then it becomes a very, very damaging. It can be damaging in nature. Okay, so friends, this is all about earthquake, and we will see more about earthquake further. Okay, now let us understand landforms. Okay, so this was the previous slide, or previous things that we have learned was about endogenetic processes or endogenetic forces. Now let us understand about surface agents or surface processes known as exogenetic processes. So exogenetic processes are responsible for creation of various landforms. Okay, so there are two types of exogenetic processes. One is known as weathering, another is known as erosion. So weathering is a process which happens on the spot. Here, material is not transported from one place to another place. So that's why it is known as in situ process or on the spot degeneration process. So when the rock is there, it gets degenerated on the spot, we call it as a weathering. If that rock is transported by the water or wind from one place to another place, we'll call it as a erosion. So remember this, in erosion, transportation of material is involved. In weathering, there is no transportation of material. Okay. So let us understand the landforms created by the different agents of erosion. Now weathering we are not going to see, neither we are going to see erosion in detail, just little bit of landforms created by the erosional agents. So there are 4 erosional agents: river, wind, sea waves and glacier. So let us understand these erosional agents, landform created by them. So first landform that will be created by the river is on the top of the mountain. That landform will be waterfall. So because of the deep erosion of a particular rock on the top of the mountain, water will fall from certain height. It will be known as waterfall. When the river reaches to the base of the mountain or it reaches to the plain, then its capacity to flow with the high speed reduces. Then river flows at very low speed, and when it flows at very low speed, the water does not flow in the straight line. Getting it? So water is not flowing in the straight line, it flows in a bent manner. So it bends, water bends. They are known as meanders. Getting it? Sometimes these meanders, okay, these meanders break, river meanders, they will break away from the river. When these meanders, they will break away from the river, the lake will be formed, which is a shape of a horseshoe or the shoe of a bull. It is known as ox bow lake. Getting it? We are going to see these things in a detail. Okay. So now these lakes have been formed, known as a oxbow lake. So now river water is very very calm. So when river water is very very calm, the deposits will, when there will be flood in the river, the deposits will spill away from the main course of the river and they will be deposited in surrounding region. So for thousands of years, millions of years, this flood will come, flood will go out, and when flood will again go out, and river will take its main course. The depositions on the banks of the rivers, or let us say few kilometers away from the river, it will create a plain. It will be known as flood plain, like we have northern plains or Ganga plains. So they are the flood plains of the river. Getting it? River bank is raised during the flood because of the sudden depositions on the river banks. So these depositions, after river recedes to its own channel, these deposits will be seen. They are known as levees. Okay, and when at the mouth of the river, where river meets the sea, river is very very slow, so it will put its own, or it will deposits its own sediments on its own path. So for example, river has come and it is very very slow. Now it will deposits its sediment on its own path. Because of that, obstruction will be created for the river, and these river will be divided into many distributaries. Getting it? So further this will be again creating further distributaries. So further, because of the deposition of these distributaries, huge amount of fertile deposits will be formed over here. They will be triangular shaped. This is known as delta. Okay. So at the mouth of the river, this triangular shaped thing will be formed. We'll call it as a delta. So this delta is formed at the mouth of the river. So this is a depositional feature of the river. Okay. So these are the various landforms created by the river. Next landform or next agent of the erosion is a sea wave. Now sea wave, as you know, it comes and continuously struck on the seashore. And on the seashore, if you have a huge mountain, it will continuously struck on that mountain. So the parts of the mountain will come down and very steep rise will be seen on the parts of the mountain. So this is known as a sea cliffs. So steep rise of the mountain on the side of the seashore is known as a sea cliff. Further erosion or further hitting of the sea waves on this mountain in the smaller surface will create a hole on the mountain. So this hole may go on deeper and deeper and deeper. So this will look like a cave. So this is known as sea cave. Further, if the sea caves become more and it goes more inside, and sometimes it comes out from another side. It is very very transparent. Now this is known as sea arc. Getting it? Now further erosion of the sea wave, this part of the sea arc will fall down, and only a wall of the sea arc will remain. This is known as a sea stack. Getting it? So these are the erosional features of the sea waves. Further, whatever material that sea waves have eroded, it will deposit it somewhere on the back side or somewhere on this side. So this will create a beautiful beach. So beaches are the sandy beaches, shingle beaches, so many types of beaches are there. Okay. So this is how sea beaches are formed because of the sea waves. Okay. Now Next agent of the erosion or last agent of the erosion is ice. This ice is nothing but a glacier, not a normal ice. It's a huge glacier. This is the most potent erosional agent. It is very, very heavy. You won't be able to find out glacier is moving. It will look like it is standing, but glacier is continuously moving. Slowly, slowly, very slowly it is moving. And because of its huge tonnage, weight, it is eroding the earth downside or mountain downside. Okay. So glacier is also known as a river of ice. Okay. So river of ice. And this glacial deposits, when glacier will melt, deposits of glacial black color you can see, it will be deposited down. They are known as glacier moraines. Okay, so this is one of the deposits created by the ice. There are so many, I told you that we are going to see almost 60-70 types of landforms, but not today. Okay, when I will come to Hyderabad, that time we are going to see. So these are the glacial moraines. Okay. Then, yeah, one more has been left, that is wind. Wind is eroding. Wind can erode mountain, wind can erode normal plain lands. Wind can, so when it is eroding, it will take out very fine particles away from this particular mountain. Getting it? So when these fine particles have been taken out, it will be converted into the sand. Okay. So this type of rock, this type of erosion is known as mushroom rock. So it is looking like a mushroom. This is because of the wind erosion. Now why it is looking like that? Because there is a hard rock and soft rock. On the top you can see this is a hard rock, mushroom shaped thing, and its stack is a soft. That's why it has eroded very fast. And the rock above could not erode very fast. That's why it has remained such a huge. So this is known as mushroom rock. Then in the desert area, wind will erode and it will carry sand along with itself and it will deposit that sand somewhere. So this deposition is known as sand dunes. The sand dune will be looking like this. Sometime this type of sand will be spread in a huge area on a huge land. This will be known as sand loess. Okay, so loess are generally found in China. So because of the certain obstruction or a wet type of surface, these sand will be accumulated in the or spread in the huge area. This is known as sand loess or sand loess. Okay, so these are the different agents of the erosion, and these are the various landforms. These are the various types of processes: endogenetic process and exogenetic processes. So I hope you guys have understood this. So we have seen two types of processes: endogenetic, exogenetic processes. Endogenetic, sudden processes and diastrophic processes. Exogenetic processes, erosion and deposition, erosion and weathering. Erosion is it's done by four agents. So four agents, which are those responsible for the erosion? You have a water, you have a ice, you have a third thing is, yes, what is the third thing? Wind. Okay. So water, ice, wind and sea waves. These are the four things which are responsible for the erosion. Okay. So I hope you guys have understood this chapter. Based on this, we are going to see MCQs. So first MCQ, which is not an erosional feature of the sea waves? Yes, cliff, beach or sea cave. So definitely beach is not an erosional feature, it is a depositional feature. Okay. The depositional feature of glacier is, okay, so definitely moraine. Beach is a depositional feature of a sea wave. Floodplain is a depositional feature of the river. Okay. Third question, which is caused by the sudden movement of the earth? So volcano is caused by the sudden movement of the earth. Okay. Mushroom rocks are found in, definitely in the desert. Oxbow lakes are found in, oxbow lakes are found in the river valleys. It is a feature of the river. Okay. Then next we have a match the following type of question, which can be considered as your MCQ type, one of the MCQs. So glacier Yes, river of ice. Meanders, what is an answer? Yes, rivers. Beach is a result of, yes, what is seashore? Waterfalls, yes, waterfall forms because of hard bedrock. So hard bedrock is, so for example, you have this type of rock. So this is a hard bed of rock, and this is a soft bed of rock. Now, this hard bed is eroding very slowly. So water flowing from here, and soft bed has eroded very fast. So soft bed erodes very fast. So water comes and falls like this. So this is known as waterfall. Okay. So waterfall is because of hard bed of rock. Earthquake, vibrations of the earth. Okay. So I hope you guys have understood this chapter, and you guys will solve these questions like this very easily. The difficult part of this will be in the 11th standard NCRT, and 8 o'clock we'll see the question. Okay. So thank you. See you tomorrow.